So the paper is about performance evaluation for the use of ELMo word embedding in cyberbullying detection tasks. As it is mentioned, the most focus of the paper is on the effect of word embedding in toxic detection tasks. The communication using the modern internet has revolutionized the ways of exchange information and provide many advantages, but its applicability is still limited due to the problems caused by the personal attacks or pseudo attacks. These problems called toxic content and may be in the form of text. As they have several consequences, it is important to have various techniques to automatically detect the toxic content from social media. These techniques are mostly based on machine learning algorithms. Since the majority of the toxic contents have text bases, sentiment analysis plays an important role in analyzing the text. It employs NLP techniques in order to identify, extract, and study the text content and find types and portions. So as it is shown in the figure, there is an NLP task divided into three main steps, which are pre-processing, generating the word representation, and applying proper learning algorithm. So basically, the classification algorithm made an input, and this input comes mainly from the word representation. So fitting strong word representation to classification methods is an important issue, which is the focus of this paper. Having this fact in mind, in this paper, we mostly focus on the effect of word embedding techniques, especially ELMo, word embedding in cyberbullying detection tasks. The contribution of this paper are, first, we combine ELMo with NLP decision tree random forest to achieve text-based cyberbullying detection, and then we conduct a comparative evaluation of the impact of ELMo word embedding on three basic machine learning algorithm model and deep learning models. And among the deep learning models, we combine ELMo with a modified dense model so that leads further improvements. As I started to the background, it is interesting to talk about the recently published survey paper by Wang et al. The authors have reviewed related words to the word embeddings techniques based on deep learning models. So the figure shows the timeline that the authors provided in this paper. As it is shown in this figure, the word embedding started by word2vec in 2013, and after a year it will be emerged. And by emerging transformers, a new generation of word embedding have been emerged. OpenAI GT, ELMo, and BERT are among them. So these models need to understand how context of a sentence affect the meaning of that word. To be more specific on the employed word embedding in this paper, I can refer to Peters et al. Paper, which is published in 2018, and is the paper that introduced the ELMo word embedding. Basically, the ELMo is the abbreviation of embedding from language model. As shown in the figure, the ELMo word embedding is based on deep bidirectional language model. As an example of the functionality of the ELMo, the purpose of this figure is to calculate the ELMo word embedding for word angry. So there's two passes, forward pass and backward pass. In the forward pass, the probability of the sequence is computed by modeling the probability of the word angry as things happen in the backward pass, but this time it used the reverse, the sequence in reverse. And at the end, both probabilities are combined together and produce the ELMo word embedding for word angry. The result of this paper is mainly compared with the results of published paper by this et al. They use two general word embedding techniques, which are BERT and word2vec, but in fact, they use three word2vec, which are the pre-trained word2vec, domain-trained word2vec, and mimicked word2vec. Based on the results, it shows that the mimicked word2vec showed better results in most of the learning algorithms. So why we choose the ELMo? One of the main reasons is that despite of being a new word embedding and the context-based technique, it can address the problem of polysemy in toxic detection tasks. So basically, polysemy means when a term in a sentence has two different meanings. In such a situation, we can take advantage of ELMo word embedding because the ELMo word representation is a weighted summation of the raw vector and the two intermediate word vectors. Thus, the assigned ELMo word vectors to a comment is a function of the whole sentence containing that word. So this way, a specific term with two or more distinct meanings has different embeddings based on the context of the sentence. Now we're going to talk about the proposed method in the study as shown in this figure. So this is a high level of the methodology. First, we have a pre-processing of the raw data, and then we choose which one to compare a deep learning model or machine learning model. And after that, we're going to generate the ELMo embeddings based on the selected model, which is a deep learning model or a machine learning model. And after that, we're going to train our models. And the pre-processing step, basically the material needed for this step is a data set, and it is important to have a valid data set. So the data set that is used in this thesis is in this paper is downloaded from the Kaggle website, and it is collected from Wikipedia Commons page by Jigsaw Company. So there are four major tasks in data pre-processing, which are data cleaning, data transformation, data integration, and data reduction. In this paper, we use data cleaning task and data transformation. Basically, the data cleaning means removing incorrect, incomplete, and inaccurate records from the data set and replacing them with appropriate data. The noisy data in text type means the URLs, emoji icons, and stop words. The stop words are the most commonly used words in any language, such as articles, prepositions, pronoun. But in this paper, we only remove URLs and emoji icons because, and we preserve some of the stop words because, for example, in this example, your face is not beautiful is a kind of toxic or bully content. But when we remove the not and is and your, it converted to face beautiful, which has like beautiful is a positive word and face is a neutral one. So then it completely changed the story and converted to a non-bully or non-toxic sentence. So the next step in the pre-processing was to transfer the text and the data to lowercase, and at the last step was to change the multi-class data set that we have into 6 single label data set. All of the above mentioned tasks are done by using a natural language toolkit, which is a famous library in natural language processing. The results of the ELMo are compared with the results from the TF-IDF, Word2Vec, and BIRD from the DCA paper. The TF-IDF is composed of 2 parts, which are the term frequency and inverse document frequency. TF means how many times a word appears in a document, and IDF illustrates how common or uncommon a word is amongst the corpus. By multiplying these 2 values together, the TF-IDF value is generated, and the Word2Vec makes vectors of the words that are distributed the numerical representation of word features. In this paper, we use the results of the mimic Word2Vec, which is presented by DCA as the baseline. The main difference between ELMo and the above mentioned word embeddings, which are Word2Vec and TF-IDF, is that the Word2Vec and TF-IDF do not consider the context of the text in a sentence during embedding generation. In order to have a fair comparison, we use the results reported by this GitL by using the BERT model, because the BERT model is a context-based. So we want to compare our context-based embedding, which is ELMo, with another context-based in order to have a fair comparison. ELMo can be implemented from two sources, all an NLP or TensorFlow. In this paper, for the deep learning model, the ELMo is implemented as the embedding layer using TensorFlow Hub. But for the tree-based and neural-based models, which are decision tree, random forest, and NLP, we go over this procedure. So at first, the clean data is converted to a dictionary with three fields, which are text, tokens, and label. And after that, the tokens are passed to the ELMo embedder function from the all-in NLP library. And then the generated word embedding is for each token, it's passed to an average function, and then we have a embedding for each token. So the last step is to use a classification model. As it was mentioned before, we use decision tree, random forest, MLP, CNN, dense, BioSCM, OSCM. So the decision tree is one of the widely used supervised machine learning models, and it can handle different types of data, nominal, numerical, textual, and so on. So the advantage is the disadvantage is the main reason for using decision tree in this detection task. So we use Gini index as the criterion, and this solitaire is the best. Moreover, we use the random forest, which composed of multiple decision trees, and the outcome of the random forest is based on the output of the decision tree using majority voting. So it means that this model has an ensemble model inside itself. Moreover, the random forest reduces the overfitting of data sets and increases precision. This is one of the main reasons that we use random forest in this paper. So the NS estimators means that how many decision trees we use in our random forest. So we use 100 decision trees, and the criterion is the Gini here. The NLP classifier provided by Skylern is used in this paper. It composed of a single layer with 100 nodes, and the dense model contains 3 layers with 1024, 64, and 1 neurons, and we use sigmoid activation function also. So we use the CNN model, which is a convolutional neural network. It has 2 layers that perform the filtering operation, and this configuration extracts more essential features from the text and can detect important features without any human supervision. So as you can see here, this is the structure of the CNN model. It has 2 convolutional layers, and there is an embedding layer before that. As for the LSTM model and BioLSTM model, they have same architecture. But in BioLSTM model, instead of using 2 LSTM layers, we use 2 BioLSTM model. In all of the models, we use the sigmoid activation function, and yeah. So after our explanation about the proposed method, in this slide, the experimental setup is explained. So the data that is used in this paper contains the comments from Wikipedia's talk page. The dataset is manually labeled with 6 labels, which are toxic, sever toxic, obscene, thread, identity, hate, insult. And the experiments were run on 5-fold cross-validation in 5 epochs with batch size of 8, and we use Google Colab with higher 26 gigabyte memory. The evaluation metrics that we use are precision, recall, F1 score. So the precision will answer what proportion of the predicted samples are toxicity, and the recall is going to answer what is the percentage of the actual toxic comments that are predicted correctly. The first task is related to comparing the effect of ELMo on machine learning models with the outcome of TF-IDF on the same model. So as it is shown, TF-IDF has better results on decision tree and random forest in terms of precision. So ELMo outperforms TF-IDF only when combined with a Milton model, similar to what is displayed in the first figure. The combination of ELMo with the NLP show better results than the combination of TF-IDF with other machine learning models. Overall, the tree-based model works better with TF-IDF for that. In general, the obtained F1 score for the combination of ELMo and MLP have about 1% improvement over the combination of the same model with TF-IDF. But for the two other models, the identity dataset shows the same or better results when the generated ELMo board embedding are fed to the random forest. In the second task, the effect of feeding ELMo board embedding to deep learning model is compared. So the proposed combination of ELMo with deep learning model outperforms mimics word-to-vec or word-to-word embedding, specifically in the LSTM model. Using ELMo board embedding improved precision with a minimum 2% and maximum 5%. However, the ELMo board embedding technique does not provide very well embedding for toxic data set among all the data sets, and that could be because of the pre-processing. So as mentioned before, the pre-processing did not act on these data sets because the subwords affect the semantic of sentence. So since the toxic data set is the largest, having more irrelevant words are unavoidable. This figure displays the results in terms of recall metrics. As shown, the combination of ELMo with deep learning model has better results than BERT and mimicked word-to-vec in most categories. And feeding ELMo board embedding to deep learning models has about minimum 1% and maximum of 4% improvement in recall. So this figure shows F1 score results from the deep learning perspective. Based on what is achieved in this experiment, the BioSTM model, which has a complex architecture, gets the best results in combination with ELMo. This combination has outdone the others with a minimum improvement of 2% and maximum improvement of 4%. It is interesting to observe that the combination of ELMo with dense model has the best results against BERT and mimicked word-to-vec in all 6 data sets. Again, ELMo does not provide good results for the toxic data. And this slide will report the comparative evaluation between all reported results. So first of all, by looking closely at the recall and precision, the results obtained on the recall are significantly better than precision ones in the combination of ELMo embedding with all machine learning and deep learning and the deep learning model. Based on the definition of precision and recall, higher recall means that the model predicts the most relevant results, and higher precision means that the model returns more relevant results than irrelevant ones. In other words, the false negative in toxic detection means that toxic comments, which are predicted as non-toxic ones, and the false positive means the non-toxic instances that are predicted as toxic comments. So toxic detection task aims to find and predict the core toxic instances and prevent the occurrence of them. Therefore, if the model predicts the toxic or good instances as a non-toxic ones, the damage is more significant. So a lower false negative can help better recall due to the nature of these tests. From the results, this can infer that TF-IDF algorithm is a good choice as a word embedding for random forest and decision tree. Moreover, the results suggest that ELMo word embedding could be a good choice for neural network-based models. Between BERT and ELMo embedding, BERT performed worse in toxic detection tests. In addition, the ELMo is a good fit as a word embedding technique for toxic detection tasks because it has a context-based characteristic. But although passing ELMo word embedding to classifier cause outperforming, generating the ELMo word embedding needs more computational resources. So applying the ELMo word embedding on a massive data set with lengthy sentences is not a wise decision. So all in all, many people are still worried about results from ICT, including fake news, insults, harassment, and so on. So these toxic contents may be in different forms like text, online chats, email, speeches, or images in social media. Throughout this paper, we try to develop two main workflows. First, we check the effect of ELMo word embedding with different learning algorithms, and after that, we're going to compare them with different word embeddings like TF-IDF, Mimic2, Wake, and BERT. So the following is a list of future works that should be studied in future. First of all, consider the effect of ELMo word embedding on the highly imbalanced data set and applying the ELMo word embedding in combination with ensemble models. And consider the use of the proposed approach in incremental learning, which is a hot topic in this era. Thank you very much for your attention.